Hello everyone, welcome back to the Shanghai Tower Grasshopper tutorial. In this part and perhaps the later part, we're going to be focusing solely on the top part, the observation deck or the crown, because in previous videos we've basically completed everything down below. All the panels, all the exception panels, the side panels, the gap infills is what we did last, as you can see here. So this time we're going to be really focusing on the crown, which requires a little bit more work, to be honest. So hopefully in this iteration we can simplify some of them in relation to the old script. Now if you zoom in here a little bit, what we want to do we might want to get rid of the left hand side V-strike panel here, just so we got that out of the way. But let me explain first what we want to do with how we want to tackle this. So we know that there's a certain floors that encompasses this crown, the spiral up basically. What we want to do is we want to have a line that literally spirals up like that, and based on that line is where we will cut the panel down there. So I'm drawing this very ugly, but I hope you can sort of get the idea of what we're trying to achieve. So this is obviously going to be not like this steep, so something like that. We'll go all the way up. This is a very bad drawing, but I hope you can get the idea, and also going to be very clear once we get to it. But like I said, let's try to actually fix this one by referencing that up here. So I'm just going to quickly do a geo surface. Not sure if we're going to fix it here or not. Actually we can, but first let me do this. Because this is a part of the crown, I was hesitant whether to include it or not into the crown area, but seeing as we're doing the crown now, we might as well just do that. So I'm just going to quickly hide that, and then I'm going to quickly do a hidden, and then I'll just call these the V-strike panels. And then what we want to do now, we need a parameter, and what the parameter will do, it allows us to group these into how many panels we want per floor, which is a parameter that we have is this 8. So I'm just going to Control C, Control Shift V over here, and then we're going to partition this into a group. So the panels, this is a number, I'm going to partition like that so that we have all the groups, and then we can focus on tree branch. Let me just quickly check that out. Let's say 120 should be around there. So yeah, so starting from 120 is where we want to start eliminating, and then we have all the rest like these. So that checks out, and then we obviously need to know where to start. We can actually use the same elements that we've used there. So I'm just going to quickly do a copy, Control Shift V. We have the floors, we have the crown. That's good, that's good. And then we can plug this in here. And then we can do a geometry, and then we can check out what's the negative. Well, the negative is the one we want to keep, so we'll keep it at there. And if we go to the positive is actually the one where we want to modify. Okay. So with that said, what we can do now is let's do a split list. And we're going to split this right in the middle, which is going to be the amount of panel we have at this moment, 8, divided by 2, which will give us the middle. And what this will enable us to do is if you select that, let's see, there we go. Then we already have this part. Now the reason why I use split actually is there could be a case where you might have to select B instead of A. Now we're not really done with this part yet, because if you look at picture that you can find online, there is a little bit that we have to do with these panels, in the sense that I think there was something like this that goes downwards or something like that. I mean, clearly this is out of scale. Actually, I can go and check quickly a picture which I've selected. I mean, this clearly is, as you can see, sort of like a back fold, you know, to the inside. I'm not sure if I have a good picture. Let me clear that off the screen. Maybe this one? No, this way too much at the top. I don't think there is really a picture. Oh, this one, yes. Well, hopefully you can still see it. It's sort of like backfolds to the inside, and that's why this part still needs some work. But at this current rate, we are able to call off the other section that don't exist actually, and achieve that like this. Pretty easy and pretty fast. So we'll hide. We'll leave this on actually. All right, now let's get to the real twist that I drew in the very bad sketch just now. I might even turn off the gap infill because does it bother me? It kind of does. So we'll turn that off. So we now are left with the curve, and we want that as a parameter. So I'm just going to quickly grab it from, well, I can grab it from here, but then I have to remake and then re-hide them. So I'm just going to quickly grab these. I might grab the merge. I'm not sure. Okay, let's grab the merge too. So I'm going to control shift. And I'm going to delete this because I don't believe that we'll need that. And as you can see, these now come from there. Now obviously we need to do the same exercise here because we don't want anything below. We just want the top ones, which we can actually just copy that one and open up this one here. And we have the top. Now we're only missing one below, so what I'm gonna do, actually I might need to take that also with us, so let's do that then. We'll copy this one too, and then this one goes in here, and then it goes like that. So instead of minus the one, we're gonna get rid of that because we do want the extra one down there, and it's actually not giving us that because we're over limit. I might have to do this here instead. So we'll do x minus 1 because we want the floor down below it, and that should give us our full 2, 6, 4, 8 values on the positive side. 120, yeah, that should be 8. Okay, now that we have our lines, which are complete from start to finish, we can start doing a what I would call sort of like tweak curves, because we want a very smooth curve down up, and we're going to do something with that curve in the sense that we want to make sure that it will align with the panelization that we will have. And you'll see what I mean a little bit, you see what I mean by that in a little bit. But first, let's focus on trying to get the surface that we need in order to make our twist. So from here, what I want to do is, these are lines. So these are actually, I will join these first. So I'm going to just do a joint line. Like this, we'll join that one. Hopefully we have one line, okay. And then we are going to make this, well, let's try exploding this. Oops, there we go. And what I achieve by this, I get all these nice points. And what I want to do with those points, in the end, I want to create an interpolated lines from this, from the vertices. So I'm just going to quickly. And the reason why I want to do all this step is now I can do a loft, right? Although this loft had to be flattened on this side to create that. Now, if I did not do this part and I just take it from this one, you'll see that it has all these lines, which is definitely not something what we want when we want to have a smooth curve. Hence, when I'm rebuilding it with this. Now, you could also argue, why not just take, which one was it? Why not just take this, or actually this one? Yeah, you can. But that will mean that you have to create a different, a new parameter from this one, and then cut it from that plane. It's doable. You can do that obviously, but because this operation is not that heavy, expensive in terms of computational power, and it maintains the linearity and the cleanliness of your code, of your script. Hence, I'm going forward with this instead. It's the same thing. Okay, now that we have this, we want to have our line that will be wrapping around this particular surface. We are going to construct our tween curves. Let's see, because what we want to do, we want to have the smooth line based on the top and the bottom curves, and then every curve in between will be tweened. Might as well just start working up, because I believe some of you would not understand, it's hard to understand what I mean by that without showing you what I'm actually going to do. Let's see, I want the top and the bottom curve, which I can extract from this one. So that's what I'm going to do. So this is the surface that we eventually want to need to wrap around our curves. And now I'm going to come in here quickly and do a list item. I do want to flatten this because I want to have the start and the end. Oh, maybe I should flatten this part first. Let's see what happens if I do that. Okay, it's still okay. So then that means I don't need to flatten these because it's already pre-flattened. So I have the start in here. And now what you can do is do a tween curve from the bottom to the top. And for the tween curve, the F is where you want the curve to input. If you have one number, it just shows you one curve. But if you have multiple curves, well, if you have multiple Fs, you get multiple curves. And for that, what we're going to do is we're going to use a range, simply because the F takes a number between 0 to 1, right? So if you plug that in here, default is about 11 values, so you got these 11 curves. Let me hide that for now. But we can actually import here a integer that plugs into the end, so it controls how many curves we want to tween. And with this, you control how smooth you want your curve to be. For example, if I put this at 50, let's start with 50 first. And we get that. And now we can do now is do a curve evaluation. Curve evaluate. And remember to parameterize that curve. So we have how many curves? 51 curves. We have 51 values here also. Now what we can do is we plug that in here. We get a series of points that, well, goes amount with our curve. So if you adjust this, you'll see that the more points you have, the smoother the curve will be. It's a very slight deviation, but there is a deviation. Of course, if you were to compare like 9 curves with 100 curves. So in the end, what I want to do is make a interpolated line here from these points. So I can actually hide all these. So observe how the curves sort of like bends here especially on this side, simply because these have a smaller radius where any changes will have slight effect. So you see that it sort of wiggles a bit because of how many points it can use to make that curve. So if I increase it to like about 100, you can see that it starts to stabilize. And since this operation isn't really that expensive, we can leave it to 100, just so we're working with a nice, very, very smooth curve. Now, we have this part and we have our curves. Now, you might think it's easier than just, all right, and well, let's start creating the panels down below. There's additional step we have to take. And I'm saying that because I've made the script 3 times already, so I can understand where the pitfalls will be. So I'm going to explain it right now. If I zoom in, oh boy, something like that, because I want you to see the white part. So that's for the sake of trying to make the point, trying to show you what's going on here. Let's assume that the green part selected actually starts from the from here, right? Let's actually assume that it starts from there. Let me take a blue one. Let's say your curve goes like this, right? And then it sort of wraps around to the top. Very important is you want to make sure that where the curve, where the twist curve or the spiral curve touches the floor, where it meets the top floor, you want it to cross the section of a panel, because that will give us, it will make our lives a lot easier when we start to make these panels. Because, for example, if I release everything and if I draw a curve that's wrong, let's say it crosses somewhere, well, that's not really a nice curve, is it? I hope I can do that. All right, this one. You see how this point is actually not at the center of, not at a junction between two panels, neither on top of the bottom. What that will create is when we go ahead and make the panels here, because what this will do is we will have to split this panel, and then you end up with a panel that's like basically a seam, a line, a very small line. Hence, we want to make sure that it always ends at where the panel starts, so that we can say, all right, then this panel is a full panel, right? And then the panel beneath it, or the panel next to it, like this one, is, well, it's going to be slanted. It's going to be chopped up diagonally from the top. So that's one preparation we have to make before we continue on with this. So let me enable that back again, because this curve only gives us a approximation, a very, very close approximation of how we want to divide it. But it doesn't give us the real curve that we want to use, right? Okay, so with that said, the way we can achieve that is we first want to identify where are the floors. And we can actually use, I believe, maybe I can use that. Yeah, we can definitely use this. So we can just do a, we can just do endpoints, because we just want a plane. We'll do an endpoint from this one, and then we just do an XY plane. Doesn't really matter from which point you select. It's a plane, you know. It's doesn't really matter. And now what we can do is we can start to do a point to plane intersection, which I don't know what it's called, but I do know it's here somewhere. It's a plane and curve, that one. So obviously P is the plane, and we got our curve, which is this one. So we plug that in here, so that we have these 5 points, right? What these points will tell us, and then if we enable this part, let me zoom into this one. You can see the problem I was talking about. The green point is where eventually the panels will be, right? But this point is not intersecting at any of these ends, and that's not what we want. We want it to intersect somewhere there. So we're going to do a little trick. We're going to do point closest. Oh, nope. We'll do point closest to point. And this one. And let me see, how many do we have here? We have 8 trees. We have 8 points, so that's okay. That checks out. Obviously it should, because it comes from the right, from the same data set. So the point to search from is this one. The point cloud to search for is this one. So that when you select that, you can see that it's highlighted whatever is close to it, and in this case it's that one, and in all the other cases it's going to be different. Okay, and now we can create our new interpolated line. Just copy this one instead. Oh yeah, we need to flatten this in order to make that point. So we can actually hide this for now. Let me hide everything and show you why we have what we're doing. You can see that the second line we made is a lot more sloppy, right? But that's where this comes in, because we know that this, the surface we made and the curve we made, is very close. It's almost touching. So the only thing we need to do is just say pull the curve to the surface. You can enable that, and then you see that is very close. So the only way we needed that was just to make sure that we have these 5 points where it intersects. And then this one doesn't change very much anymore, so you can leave that at 50 if it's your computer is taking a hit, but you can also leave it at 80. As you can see, it doesn't really make a difference. So as long as it has enough points, because up to a certain threshold, the rate of return, the changes that you get is very minimal. So that doesn't really matter as much. So we can now disable that. We don't need this anymore since we have our line like that. And this line will definitely cross all the points that we have. You can, let's do a small check. Let's check this one. Whoa, whoa. You see how it crosses exactly this point. Is where a panel also ends. Okay, so with that said, let's go back to a nice view like this, maybe like that. And then we'll pick up the next step from here, which is actually just to make the standard panel first that are not being cut by our line. For the standard panel, we can actually utilize this part of the component here, and we're just gonna let's do this instead. We'll grab these curves that we want to manipulate in the end, so it's easier for us to select. And let me quickly check the order of these points, of these lines. So it starts at the bottom. This one also is at the bottom. Okay, that's good. And now, just to be sure, I'm gonna do point closest to the curve. And what this also gives us is the t parameter, which we can use to explode or shatter our curve. I believe we might have to graph somewhere here. Let me try this. I'll do a list item on that one. 7 values. Wait, we have 8 values here. Okay. So I think we have to graph. Oh, not flatten. We'll have to graph this one. We'll graph that one too. So in the end, probably should graph here instead. So that in the end, we're saying basically, let me turn this all off. And if I reverse this, we should have the curves that we want. We're gonna fix the top one later, so don't worry about that. The reason is we want to make sure that every point from here, okay, gets to be applied to only one curve. Hence, the grafting sort of like forces the data structure to work the same way that we want it to work. Flatten, in all sense, should actually work, but this just gives us the assurance that we are actually doing with the data that we want it to do, and we're expecting results that we're getting the expected results, basically is what I want to say. So if I just hide this briefly, and let's quickly fix the bottom and the 2. So we're just going to use a normal call index, and let me see, I can actually flatten this, and I'll put this as 0. So I'm going to probably do a double flatten. So now I'll remove the bottom part. Do I need the bottom part? Not too sure. I mean, if I do need, I can come back for it. So that should be fine. Actually, what I prefer is remove the top part first and then the bottom part. So we now end up with the 6 curve exactly. So now if we do an explode of these curve, okay, we get our sections back. And what we can do with this section is, let's see, let me double check. We can do this section is merge these down, but I think we might have to get not include that one. And the reason for it being if I were to say extrude down, I need a floor. Do I have floors? Floor height? No, I don't have floor height. So I'm just gonna quickly go and grab that from here. Floor height? This one. So I'm gonna Control C, Control Shift V here. I'm gonna make a Z axis from it. And I'm gonna drag it all the way here. And I'm gonna give you a negative value so that you extrude down. Here's what happens if I don't get rid of that part. So let me hide this. Let me hide that one too. And extrude. So it all looks good, right? All the full panels underneath the curve is now done. And if you quickly look here, we have an overlapping panel that's sticking out. You might be able to see it this way. No? Or this way? Yeah. You can see that that panel should not be there. So we're just going to quickly do another call of index. We might have to reverse. Let's check where is the first. Well, the first one is there, so that's not the one we want. We actually want the reverse. So if you want to do reverse, you see that they're all selected that panel, the one which we want to get rid of. Let me take that to the right place. Actually, let's hide those. Actually, I want to show this one still. Okay, so with that verified, we'll go in here. We'll say let's remove index 0, reverse, double reverse, so they're removing that part. And if we hide that, you see that we're not selecting the last panel, which we already have it made in a previous part. All right, so now we can actually, well, to hide the line or not, it's up to you. We still have to fix the very, very top part. Maybe just replace that in the end, but that's a little thing that we can touch up in the end. So that's not a really big issue that we have to fix now. But this is what we achieved so far. And the next part obviously is going to focusing on the panels down here. Now that's, I would say that's a very interesting part, because at the end, if we continue on with this, we'll get like a super small panel, which not sure if we want that. But I think in production, if this thing were in production, so it's going to be fixed. I think they have a way to combat that also. So we'll take a look at that next. So in order for us to make the panels underneath this diagonal curve that we made, we need to understand what happens there. So I want to take a look at this screenshot right here. Is if I take my pen and I can draw on it, what you'll notice is I want to direct your attention to let's say about here, this one. As you can see from this point, we can safely assume, right, that is where the panels we have made, right? If this were the curve that goes like this, which I'm just overdrawing it, we'll assume that this will not be here. It doesn't make sense for us to make that. So let's say this is the full panel. And what you notice is normally we take the top one, the top curve over there, and then we extrude down, right? This still applies to these panels, but at a certain point you'll see that this panel, this one, is a lot thicker. And what you notice is this one follows the division, right, that we have if you were to extrude from the top. And then all of a sudden, it takes on the division that you have from the bottom. So let's say this one. Oh, I should probably take a different color. Selected that. There we go. So this one takes a different color. I mean a different division. And then we have this thicker panel here, which acts as this transition panel that can bridges the divisioning from that you take from the bottom to a different segmentation, right? So there is a little slight detail going on here in order to make sure that probably so that you won't have um, a weird small panel there, or very weird way of making this aluminum profile here that you see at the bottom. So we'll try to mitigate, I'll try to imitate the same thing. We'll try to make this also in our script, but this is the theory that we're going to have to try to work out, right? So I think first we focus on where do you want to make this transition. So with that said, let's clean this up. Okay, to start off, let's identify where we want to have our transition. I turned off a lot of unnecessary geometries on the screen, for example, the white outlines, so that we can focus on this a little bit better. We have this curve, but we also have the complete version here, so we might want to take use of that. So I'm just going to quickly actually copy this one instead, so that we still have everything, and then we can work on that way. But we need to identify where we want to have the transition. So I'm just going to quickly poke around until I see something that we can use. Maybe not this one. Actually, this one maybe. Yeah, so the start, or actually this one. Yeah, we can actually take that one. So I'm just going to quickly turn that off and apply this from here. We don't need the top, we just want the bottom one. So, and let me do a simple list item, and we'll do a integer. We'll just say from 2 to 10. Just pick 7. And what this does is, you can see the green dot. That's where we want to signify where we want to have the transition part. So I might just quickly put that here, and I'll just kind of give it a name so that we can know what it's all about. Transition point, something like that. And to make it, we'll give this a name, and we'll connect everything here so that it's a little bit easier to see what we're doing over there. There we go. So now we can actually turn it off or not. Now, and then we want to have this point, right, to tell us essentially where we want to cut from the to separate the bottom curve with the to separate the top curve with the bottom curve. So we're just gonna quickly do a SDL. We can actually do this SDL line, and this is gonna go up. This is just gonna help us, and the amount you're gonna go up. Well, we can't apply the floor height there, which is totally fine. Is that a number? Nope. Yeah, no, that's a negative. Well, actually, I can still use that. I just have to double negative this, actually. But let's take from this then. So we will have a line here, and this line will help us cut our diagonal curve. Before we can do that, we're just going to quickly come in here and let's do a curve-to-curve proximity so that we can have a point, this curve, approximate to our diagonal curve. Where is that? Oh, this one. There we go. Well, actually, no, we actually want this one instead. We don't want to cut that diagonal curve. We want to have the point. So we might have to be content with that. But first, let's remove the very top one. So I'm just going to copy this one. I think this one removes the top, right? Yeah, it does. So we can plug that in here. There is a bit of an issue with grafting and point, so we're just going to quickly flatten this part. Actually, no, the graph was okay. We just need to graph this one instead. So I'm just going to graph here so that we can have one point each, although the ordering of these curves are not really the same. Let's see. Let's have a close look how we're going to solve this. Wait, okay, let's try the flattening first. So if we flatten this part, I don't like that particular curve over there. Aha, I see. Well, wait, let me check. How is my curve actually organized? So that's number one. What's number one here? Number one here is at the bottom. Aha, we actually don't want that. We do want the top curve. My apologies. So let's get rid of these reverses so that we have that curve, and we're gonna see that's, yeah, this is about right. This is where we sort of want our curve to be cut off. I'm actually looking at the top one, whether or not we're doing this part right. Looks like it. So it looks like it. Okay, that'll be okay. I think we have additional curve. Well, we have 7 values and 7. Okay, that should look fine. That actually looks okay. So now, what we can do is we shatter. We shatter these curves with the. We're gonna have to do a curve closest point in order to get a parameter out of these. So we're gonna quickly say, where are the points? Point on curve B closest to curve A. Curve on point B. No, wait, this is point on curve B, which we want the A one, because we want to point on curve A, because A is the one we want to shatter. So with that, we're gonna hide this, we don't need to see this, and then we can say shatter this one. And we'll end up with, I think this is another case where we have to graph everything in order to make sure that the shattering works fine. So we're just gonna graph all these. And we have those values, that's good. And then we can do a list item, which is not selecting the right item. So I'm just gonna quickly reverse the list so that we can select the ones we want to keep. And now, if we do a explode, because we know these are polylines, right? We get this part. We just need to find a way to eliminate that part. But that's the one of the transitional part that makes the transition panel a little bit wider than they should be. Okay. One quick way to fix that will obviously just to take it away by calling a 0, and then we can delete that. There we go. Oh, accidentally knocked my mouse, so we can have this one. All right. Now that we have this part, the next part we can try to do is, let me hide this for now. I don't know why that was, what's that? Oh, okay. Don't need to see that. Don't need to really see that too. Actually, I might hide this one too. It's getting a little bit distracting. Okay. And now we want to focus on the lower part, because this one, I'm just gonna visualize this quickly like this. And now we want to have the, because we have this, we can easily move this down and it will be here. And then we now want the lower part, not coming from the top curve, but coming from the lower curve, because that's where they align. So let me get rid of this and quickly come back here and see where is the curve. I think, this one. So we just need to find out where was the culling transition point. Actually, if I look at this, we might be able to just do a split list instead, so we can reuse the other side of the split. Because if we split list like this, let me drag this a little bit down so we can see that better. So we're basically using B if you look at the first branch, we have 131 items, and if we look at this, we have 100. Where is it? 38. Wait, this is vertices. Oh, right. No, but this is still fun. We can keep it like this. This is for a different cause. I thought it was this is just to make that line. But if we hide that, let's see which one we have. We do want that one, so we can actually take these points and we'll move a little bit here. And then if we were to move, let's see, these points down with our Z, hide that, we actually get the correct points that we want in order to make our line. So with that, we if we take a look at the top view, we should be able to make a line that should fit nicely. And then you notice there's going to be something weird going on once we make that line. So first, let's try to make sure that we have this in the right group first. So we got these part, and then we got these part. And the data tree, if let's pull up a param viewer so I don't have to mouse over it every time. So if I simplify this, this is a nice tree. If I look at this one, I don't know what that looks like, but it's definitely not something that we want. Definitely not like this. So I think somewhere along this way we might have to simplify things a little bit further. If I simplify here, it doesn't do anything. So in this case, we'll just do a tree trim to cut off the extending branches to end up with 7 branches, same equal as the one on top. And now if we were to do a merge from you and you, we should get same one, and the items will be added together. There's a different story if the items are added in the right order, which we will see right now. Which I don't see anything happening. That's kind of weird. Do I even have a curve? I do. Just don't know where my curves are. Wait, these are all points, so they should align correctly. Let me see. Something is weird going on here. So that's point number 1. Let's do 11. So point number 1. And then if I look at the number of how they're organized, I would say that these are all fine. So I'm not sure why this one is not working, but let's do a polyline instead. Polyline. No idea why this one is not working, but we'll kill that one then. So we got these. Oh, aha. So there is a line somewhere that is 0 length. I think it should be at the top. Or it could be at the top, which is why it's giving us this error. So we might have to fix that quickly. Let's see. Well, how many items do we have here? 26. Well, this is definitely not 26. So we got, we might as well just clean it up from the top, right about there. So this actually gives us, okay, instead of exploding it, let's try discontinuity, because we know that, yeah, so it's double exploded, and then we just got rid of that line instead, and now we're exploding again. So every line segment has a duplicate point in there, which we don't want, obviously. Or the easy way would be if I just call, maybe that will work. Yeah, that would definitely work if I just move this up a little bit to the left, to the right actually. If I call item number 1, I'm just going to be removing 1 point. So if I call the other way, I'm going to be moving the other point. And for this to work, I actually want to retain, maybe if I didn't call that point, I think this is a little bit double. We might get away with just calling it like this. Because if I show this, the reason why we did this is to get rid of the first segment. What we should have done is simply not take that point instead. So if I were to plug this in, and we'll get rid of this, we'll get rid of that. We don't need this tree anymore because the data structure, if it's simplified, is already good enough. So we'll just take this away. And then we have get rid of the error. So I'm just going to quickly hide those so we don't need to see that. Like I mentioned, there's going to be a weird thing going on. So if I look closely here, if I let's say highlight this, I mean this is still not very visible, but if you move on, you can start seeing it start to get visible the more you get to the other side, to the smaller radius. So you see this little kink here. This is because of the difference between the segmentation of the panels between the bottom and the top. So this one is very visible. This one fairly visible. This one not so much. This one extremely, and so on and so forth. So there's a way we can fix this, right? So we can keep this for now. Let's move to a place where it's visible so we can see the change that we made will be also visible. So what we want here, and this one is a good example to highlighter. I need a pen. Where's my pen? That one. So this one is very easy to solve. What we want to do is we want to have, if this is the point, we want to slowly have this point be very near this side than that side. And then as it go along this line, we want to have slightly like this. So it's a gradual transitioning from the bottom curve to the top curve. And transitioning over this kind of panels will make this kink right there almost invisible, or not as dominant as it is now. So we need to modify these points. And one quick way to do that is if we take these points, and then we're just going to quickly do a point closest to a curve, point closest to curve, this one. So the point is obviously going to be this one. We're going to move this a little bit on that side, and the curve we want to have is the bottom curve, which we have to come back here and look for it. Is it this one? I think it's that one, yeah. So it is that one. Do we have them also here? No, I don't think we do. So how many points we have now? We have, this is 6, and this is 7. That's because, let me see, 1, 2, because we're not including that one, which we do want that one at the bottom. We are missing that curve. That's just why we're missing one. So I might have to take this one instead, or actually this one, because this one eliminates the bottom. I actually want the bottom one, and none of these combinations. Oh wait, this one. This combination does give me that. So I'm just gonna quickly disable that, and I'll take this one instead. So we might have to graph this. So I'm just going to quickly put in a curve in between here. Yeah, I'll probably need to graph this. So I'm just going to simplify and then graph it again. I don't need to simplify since the tree. How does it look like? Yeah, let's best just do it. Like best practice. This is already simplified, so I'm just gonna quickly do this. And what you'll see is they will have a point that's closest to the other side. And what I can do with this now is I can quickly draw a line between these very small differences in distances. Between that, well, let's just take this as A, this one as B. And what this will create is if I zoom into, let's say, this one, you see that there's a small green line there. What we can do with the green line is we can do a curve evaluate. Let's see this one. We'll plug in here, we'll parameterize it, and then we can shift it ever so slightly to make the gradual transition. So I'm just going to leave this camera angle here, and then we'll see the effect on our screen once we have done this part. We'll just, where is that point? Is that this point? Oh, that's this point. Yeah, okay. So we're going to do a range, right? Because this one is reparameterized, so it accepts a number from the domain 0 to 1. And we have varying differences of number. So we're just going to quickly do a list item, list length here, and then we'll plug that in here, and this will give us 7 branches of domain. We'll quickly simplify this again because this one is simplified, and then we can actually add it here. I think we need to swap the domain, so I'm just going to quickly come in here and edit. Actually, no, to make sure that we've correctly swapped the domain, we're just going to do 1 to 0 because standard is 0 to 1. So I'm going to swap that, and if I click on the green line, the green point, you can see that this point starts here, very close to the original, and then as you move up, it will slowly transition to the other side. So I'm just going to hide everything. I'm just going to plug this point right there, and then you can see that suddenly you don't see those kinks anymore. So I switch to the top view. I believe one of the kinks was here. It's very dominant. If you want to see the difference, you can actually plug in this one back here. This one is a very good difference. So if I do this and see what happens if I plug this in here, you'll see that the transition is a lot smoother. It's near impossible to spot where you start transition. Well, you can spot it if you look at the wider panel, but that's unavoidable by design. All right, now we can actually close this one, and we'll clean that up. We can actually, well, we'll leave it on for now. And now the other part, now we have the bottom one completed, the segments, let's say. We need to have, let me turn this line back on. We need to have the same one that follows this diagonal line. To get the diagonal line, it's we'll use the technique that we've already used here, which is using an SDL line that goes up, and then we find the closest point to that curve, diagonal line, then we turn those points into polylines. So let's do that. We got this one here, and then we're gonna just do an SDL. Let's actually explode our curve, which is this one. Or we can just use these points instead, to be honest. Because I was thinking exploding this and then use the vertex, but I can actually, looking back, we can actually use this one instead. We'll just do this. And I believe our Z, can we still use this right here? It's a little bit messy, but it does the job. So we're just gonna quickly do this one here. There we go. Just to, let's see. Yeah, so that should be okay. Okay, now we have a tree, and now we can do a curve-to-curve proximity. I'll just copy that one. Now we want this one, so we plug that into A already, and then we plug these into B. And this will give us in B the points that we need. And if we turn this into a polyline, we turn that one off. Now this polyline is going to be very similar to this one, with the latter one being that it's a polyline, meaning it's segmented already. So if I quickly do this instead, the gap over there, we might have to do something with it, because I don't think that's going to make a nice, how do you say, a nice, well, surface. Oh, you see what I mean. If I quickly, let's see, I can actually turn this on now. Okay, I need to explode both these. I'm just gonna do that. So this one oh, this one is exploded. That one is exploded. I don't need to see this. So now we can actually combine this into a merge, graph these, because so that each element goes to their own. And we're just gonna do a simplify. We'll graph and simplify from here, or yeah, we can do it here. I was thinking we can do it in the merge, but it doesn't really matter now. We can just do it. If we do it here, we don't have to do it in a merge, basically. So we got that, and now if we say loft everything, we get nice, still vertical curves that stops and begins exactly there with the fat panel, the transition panel. I feel a little bit bad calling it the fat panel, but as you can see how it transitions very nicely to the top. And then if you roll the way to the top here, the same goes for this one. We might come in here having to fix that one. Something weird happened there, actually, if I look closely. I noticed that we have a very small strip here. I think the first thing we can solve is that one first, but that strip comes from these two, which they generated 2 points that are very close to each other, which I think stems from this part right there, and same from this one, because of the I think we might have to get rid of. So if I look back here, the problem seems to stem from that we have an additional point, like we have there here, so that we can get rid of. I don't seem to see the point there. So the point comes from here, which in turns comes from that last segment that we did. Or it could be from this one actually. Hold on. So we got, what are the list that we get from here? So we got 14, 14, 14, 14. And let's do a param viewer to see what our inputs of lines are. The 14, 14, 14, and then gives, oh, I should actually look at this, not the list, but rather these. Aha, see? There's always one extra item here that we don't want it to include. So what that gives us, what that tells us, we have to say this n is -1. And there we go. We got rid of it. And it also makes everything cleaner. The reason why we don't see it here is because it's probably so small that you really don't see it. But in this case, we do. So now we have exactly the same amount of data going to the same amount of lines that we have. So that's a quick fix for that. And now we can actually hide everything back up. And for the last panel, well, the top is okay. It's just that the bottom is not. You know what, I'm just going to quickly bake this, since moving around with the mouse is really difficult now. Yeah, this is a lot better. Should have probably done this long ago. This is actually the panel that we already have. So as you can see here, the green one, we want the top and only the top. As for the rest, well, they don't really exactly align, so we might want to just cut this panel up using that line over there. I mean, just get rid of the V-stripe panel over there. So we just can, is it this one? It's none of these. Okay. So with that said, with the theory, the plan set, let's see if I can call this off so that we can modify it. This list is flattened. I think I might have done that off video. We'll call 0, and then we'll turn this off, and then quickly we do a double reverse so that we are isolated that panel, and then in the other ones, actually, I mean, yes, this is so fine. So we just need to do this one. We'll do a list item. So this is the rest that we want, and we'll do a double reverse here so that we are selecting only this item, only this panel. The way I want to approach is actually take that point here, somewhere around here, cut this panel, and then retain the rest. And for the V-Strike panel that we make, we'll just exclude that. We can actually do that right now. I think it's this one. So what we're gonna do, this is already a list. Let's call. You can, however, do a system a checking mechanism here, because this panel is always going to be the top. If you take the center point or something like that, and then you sort it by their z coordinates, you will always get this panel at the last, if that's necessary at all. So what we're going to see, we'll just quickly do this, and we are going to do a double reverse so that everything else from the beginning to the top all the way here is going to be called, except, I mean, everything's going to stay except for the last panel. So we fixed that part over there. So we just need to have this part. I'm just going to include that to the group. That's the only thing we added now to that group. So to correct this, we can use the information that we already have back in here, which is the curve for the V-stripe. So we can use that to sort of like cut that in half. And looking back at the group, the general panel surface, because that's where we put our V-stripe panels, not this one. If we go back one more, we can have the curve, which is this one. Let's see how this is now sorted. It's been sorted into groups, so we might want to move one back. It seems like this is the one we need. And these are the ones on top. Okay. Right. So we might choose this one instead. This basically are the curve, or actually, if I look closely, I want the one where it overstands. So I want this one instead. So I'm just going to quickly make a curve. Okay. Or I should take this one too, but that's double curve. I don't want double curve, so I'm just going to make that here. And hide everything else. I'm just going to quickly say, we'll hide that. We'll just drag that in here, but because it's only be used for this specific part. I'm just gonna say V-stripe bottom curves, like that. So I need to filter out the ones that I need. I don't need the very top one. I just need the one of the last one. So I can actually use this right there. So I'm just gonna quickly come in here and do list item, and the one I want is the last one. So if I reverse this, this becomes 26. So observe what happens if I do a tree branch, for example, to select the tree branch. And just to make sure that these are simplified, I'm just going to double simplify it. And what I've done is I select the top one. But like I said, I want the one that's one below. So instead of choosing 0 here, I'm just going to click here and say 1. And then I have that one. The reason why I can hard code this in is because they're all linked together because it comes from this tree. Because if I have a higher tower, then the number will just rise accordingly, and I always want the one below the very top, and this will give me just what I need. And I'm just gonna quickly go all the way up, and I think here is where we need it. A little bit messy, but if you follow along, you should be able to see what's going on still, I hope. Alright, now that we have the curve that we can use, let's start to dissect this one. So we're gonna do a brep deconstruct. Okay, so we can deconstruct that, and we're quickly gonna do a curve evaluate from the edges. So we're quickly gonna reparameterize this. We're gonna say 0.5. The reason why we're doing this, we want to sort them accordingly by the point. So we're going to deconstruct the point, because we know the one with the lowest z-axis z value is going to be the one we want to cut, and the one with the highest is the one that we eventually want to reuse, and whatever's between, well, that doesn't really matter as much. So if I quickly do a sort by the z, we'll asynchronize sort that one, so that I can actually come in here and say list item from that will give me the bottom curve. And now I can do a curve to curve intersection, which I forgot what it was. I'm just going to take this one, curve to curve intersection, like that, and then I can shatter my curve. Okay, I'm shattering this curve. Based on that, I'm going to reuse a list item here, and then I can hide all that, and I can get my curve. Now you may be wondering, like, okay, what's the chances that it will probably get this one instead? There is a chance. There's obviously a chance. We can solve that by saying, if you do want to, but at this point it's one panel. I will leave it up to you if you want to do it. You can try to say, all right, the curve where this point resides is going to be, because this is going to be very small, that I don't foresee a case where the edge that we don't want is going to be longer than the edge we want. Or you can also do a length valuation, so that we can always take the longest curve. But at this point, this works pretty well for us. So I'm just going to leave it like that. And I'm going to quickly come in here and select the top curve. And then I can do a loft between these two. Might want to flatten that. How many curves do I have? Oh, I have a lot of curves. Why is that? Oh, right. Yeah, I actually need to join this curve, because I'm trying to find intersection for 8 curves when I just actually want one. So if I join them together, it becomes one curve, and then I will have one line. As you can see here, we need to do something with the flips of the curve. So we'll just do that quickly, and then we'll do this. It doesn't matter which curve you flip, you just need to flip one curve. And then if you can, take that out, and we hide that part, and we have our nice little curves. So we can actually merge this together now. So I'm just gonna hide that and go up in here. This is one, and we got that settled. There we go. So these are all the panels that we have that's residing on the top floor. We can do some housekeeping in a way. What are these? These are the I'm gonna keep them as is for here. I might just drag them all the way. Yeah, I'm gonna drag them all the way here. Same for this one. And let me delete the ones that I baked so that I can actually easily select them. And then right off the bat, my mouse is going haywire again. Alright, so this is gonna be the outer panel. So we just do a for this we'll just do a entwine instead, so they can select them out easily later on. So this is that. Actually no, I'm just gonna rename it because I'm not sure if we're gonna be needing this later on. So we're just gonna take this and call this general top crown full panels. There we go. And this one we're gonna call crown exception panels. There we go. And then this one is gonna be called, what is this? Oh, this is the V strike crown. Let's see, V strike panels, which takes from here. And what is, oh right, oh, and this is full V strike panels. Might want to add in a dash there just to make sure that we have the naming scheme all correct. Oops, like that. There we go. I didn't include the exception panel on the end because I think in the end we'll just clump everything together, but this should do for this part. What is this one? Oh, that's that. Okay, I see. We'll just copy a new text here. We'll paste it around here and we just call it a crown panel surfaces, even though not all of them is that, but they should give us a clear idea of what we have down in here. All right, we're getting quite there. Almost now at least we have the full panelization of the entire tower. So if I turn that on, we can see what we have. So we have everything else, right? Everything's still parametrically modifiable. Up to the crown with the little detail here, the soft transition and everything. And now after this we can move on to the inner workings or the inside of the crown, and that should be quite interesting to do. I think this is one of the very hard part because of the logic behind all that culling and lofting. But I hope you could still follow along. It's been a long video, this one, I believe. But now we have one of the hardest part behind our back, so we can focus on the smaller bits and then we'll finish it up. Hopefully in the next 1 or 2 parts that we'll have the complete tower. And as for always, I hope you learned something new in this part, and I'll see you in the next one.